In this last video for the chapter, we're going to look at the forces between two molecules and how that force affects the different properties of covalent bonds. So the first thing we're going to start off with is just the kind of definition of what an intermolecular force is. And an intermolecular force is the attraction between molecules. You want to think like an interstate goes between states, and intermolecular force goes between molecules. Now this intermolecular force, I'm just going to put IF for intermolecular force, okay, is actually weaker than the bond between atoms in either a covalent or an ionic bond. So they're overall weaker, so it's easier to break the attraction between two molecules than to actually break the actual molecule apart. And intermolecular forces do vary in strength. Alright, let's look at the types of intermolecular forces, and there are 3 of them. Okay, the first type is what we call a dispersion force. Okay, and I'm just going to give you the definition and I'm going to explain a little more about what it is. And it is the force between two nonpolar molecules, and it lasts for a short time because there is no positive or negative end to a nonpolar molecule. So what happens is this positive and negative end is due to moving electrons. So for example, if I have O2, okay, so I have an O, double bond into an O, I have an O, double bond into an O. Okay, these are nonpolar molecules because their electronegativity difference is the same. They both want electrons equally because they're the same thing. So what ends up happening is that these electrons, okay, are moving around this entire molecule. Okay, electrons never stay still. We draw them as lone pairs, okay, but in reality, everything moves, including the bonded ones, a little bit to one side or the other. So what can happen here is as these ones are maybe moving, okay, and they move a little bit this way, now I've got more negative on this end and less negative on the left end. So this molecule becomes a little bit of positive charge and a negative charge on each side. Well, if it finds another molecule, okay, that is nonpolar, and maybe on this one, the electrons are moving this way. So now I've got a little bit of a negative end and a little bit of a positive end. What happens then, positives and negatives attract, so we end up with a little attraction between these two O's. Now it's not an actual bond, it's just kind of like a magnetic attraction. But as soon as these electrons move back over here, now I'm no longer positive and negative, and this force between the two will break. So since there's no set positive or negative end, the positive negative end is only due to these electrons moving around. These are very short and very weak, okay, attractions. These are the weakest of the 3 that we're going to look at. All right, let's look at the next one. This force is called a dipole force. And again, I'm going to give you the definition and then I'll explain. This is the force between two polar molecules, okay, and these ones are going to be stronger than the dispersion because I have a positive and negative end that's set, okay. Even though the electrons are moving, so I have a little bit of a dispersion force in these dipoles. The major force is a dipole. So let's look at what I mean by dipole. So if I have two polar molecules, HCl, okay, I'm just going to have the negative side over here by chlorine, positive side over here by hydrogen, And really I should draw them as little partial charges, okay? It's not like I have an ionic bond, okay, and they're partially positive and negative. But I'll draw them as normal just for easier. All right, well, if I have another HCl molecule next to it, they're going to align, or when they align, okay, the positive will be next to the negative, to end up then with an attraction between the positive and the negative. The chlorine is going to want to be attracted to the positive hydrogen. So since these are not moving, these are set because chlorine is more electronegative than hydrogen, okay? So these electrons are going to want to sit next to chlorine. This is a much stronger attraction. It's not a short time one, it's forever how long these are close to one another and they're going to stick to one another. And that's a dipole. Dipole meaning two poles, positive and a negative. Okay, let's look at the third one. It's actually kind of a form of a dipole. It's called hydrogen bonding. And this is between an H, okay, on one atom, and either an F, an O, or an N on another atom. And this is going to be due to the fact that H is almost kind of a metal in a sense because it only has one positive, one proton, and one electron. So it can be very positive. And then F, O, and N are very electronegative, with F being the most and N and O being very close to that. So when we have a hydrogen bond, I'm going to have something like water. The reason water does a lot of things that it does is due to a hydrogen bond. So I have one water, which is H2O, so two H's, and O. Got my little lone pair on my O. Okay, O is more electronegative, so it's going to be the negative end. Hydrogen is less electronegative, it's going to be the positive end. Electrons are going to sit down here. So what's going to happen is another water molecule is going to come along, and the O is going to want to be attracted to the H. Because this is my negative, positive, and they're going to be attracted to one another. Well, this attraction happens then with every single H and all of the O's in water. And we end up with a very strong attraction. These are the strongest intermolecular force. They're actually so strong that they are considering actually naming them their own type of bond. But they haven't quite done that yet. And that's kind of cutting edge science there. Okay, so this attraction for right now is the strongest of any type of intermolecular force. Okay, so now let's look at the forces and the properties. Okay, the weak forces between molecules results in low boiling points and melting points because they're easy to break the attractions between. They're not bonds, they're attractions. Okay, many molecular substances also will exist as gases or will vaporize very easily, usually meaning they have kind of a smell to them. Okay. Since the hardness of a solid substance depends on the intermolecular force between individual molecules, many covalent molecules are relatively soft. All right. They're not as brittle as an ionic bond because they don't have a set positive, negative, negative, positive kind of crystal lattice. They are just attracted to one another in kind of amorphous shapes, meaning like blobs. Okay. We do have one type of covalent bond though that is in pretty much opposite properties of other covalent bonds, and these are called covalent network solids. These are solids that are composed of atoms interconnected by a network of covalent bonds. Quartz and diamond are very good examples of this. They take these big pyramid shapes with every time that those interconnect, that's like a carbon. And they have hydrogen and oxygen, and they have very set, very stable shapes that they take. And so what happens is these are actually very brittle. They have very high melting points, actually usually higher than any ionic bond, and they are very hard. Okay, diamond and quartz are very hard structures. Okay, so we do have a couple of things here to look at with covalent network solids, and some very good examples that you should know about.